Hi everyone, this is Soumya Paul, a mentor at Codekerdos and a software developer at Google, and I welcome all of you to day 17 of our system design series. Now, in the previous video of our system design series, we learned the types of scaling. Okay, we learned the types of scaling, and what were the types of scaling? So there were two types of scaling. First was horizontal scaling, and second was vertical scaling. Okay, these were the two types of scaling. Now we saw what these two types of scaling are. But now in today's video, we will be seeing what are the limitations of both of these types of scaling. So the first thing we'll see is limitations of vertical scaling. Okay. So what are the limitations of vertical scaling? Now there are two limitations of vertical scaling. The first limitation is something called as SPOF, single point of failure. Okay, single point of failure. Now isn't this quite obvious? What do we do in vertical scaling? In vertical scaling, we try to increase the specifications of a single device as much as possible. So, for example, we have some X amount of, we had a router which can handle about X amount of requests per second, X requests per second. Okay. Now, and suppose this router has a C capacity. Now, if my web app or any software that I have becomes a lot more popular, and all of a sudden I am getting 2x requests per second, then in horizontal scaling, we used to have two servers, but now we will have just one server, which is a bigger version with 2C capacity. So the problem here is that we end up having a single point of failure, one single bottleneck. Here, this server was the single bottleneck. Here also, this server is the single bottleneck. If by chance this server fails, all the 2x requests per second will fail. Each and every one of those requests will fail. Each and every one of those customers will be dissatisfied. But if I had multiple servers, then one server, suppose I have two servers for serving 2x requests per second. So one server will be serving x requests per second. So if just one of those servers fail, the other server will still be serving 50% of the requests. So at any point in time, I am not having a complete shutdown of my services. Some percentage of the users may not be able to access it, but some percentage will be able to access it. So this is the advantage of horizontal scaling, but a con or a limitation of vertical scaling that you have everything at a single bottleneck. This is called as a single point of failure. The second thing is called as, the second limitation is limitation of hardware. Okay. Every hardware has a limit. You can go from C to 2C, then 2C to 3C, 4C, 5C, but there will be a limit, right? You cannot go till infinity, isn't it? You can never go till infinity. Every hardware on this planet Earth has some limitation. So once we reach that limitation, after that certain point, we cannot do vertical scaling anymore. So this is another limitation of vertical scaling. Now let us take a look at limitations of horizontal scaling. Okay. So we'll see two limitations of horizontal scaling as well. So what are those two limitations? The first limitation is something called as consistency of data. Consistency of data. What does this even mean, consistency of data? This means that if we have horizontal scaling, we might be facing problems in maintaining consistency of data. For some periods of time, the users may see inconsistent data. For example, you have a lot of data in your database. Okay. And you have a lot of requests coming to your database as well. Now, if you have a lot of requests coming to your database, you want to distribute the load into multiple servers. Okay. So for example, too many requests hitting a database. Okay, so here you have, say we have something like, earlier we had just one database, DB1, and it was able to handle X requests per second. Okay. But now suppose all of a sudden we have 5x requests per second. So what we do is, here we have a load balancer, and then we have 5 different databases, DB1, DB2, similarly DB3, DB4, and DB5. And then this load balancer will be sending some X requests here, some X requests here, some X requests here, some X requests here, and some X requests here. And all of these DBs are identical to the previous specification that we had. So now our entire system is able to handle 5x requests per second, isn't it? But the problem is that we have to spend more data, more money on the infrastructure. Earlier we could do with just one database. Now we need 5 identical databases. And each of these databases contain the exact same data. Okay. Each of these databases contain the exact same data. So that is what we want. Okay. So each of these databases contain the exact same data. So now, if there is some update happening to a single database, suppose there is some update happening in database 3, some data change in database 3, that change must be reflected in all other databases. And if before that change getting reflected in, say, DB2, a request comes in DB2 to fetch the same data, so then DB2 will be serving the previous older stale data. Got it? That is the problem. So when we have distributed our load in horizontal scaling, some of our databases, whenever one database is getting some updates, we need to replicate that data. We need to propagate that data to all other databases. And that will take some time, isn't it? That will take some time. And by the time before the replication, before the propagation of data update happens in all the databases, if the other database gets some request for that data, then that database will be serving old data, not the new updated data. And that is called as inconsistent serving of data. Got it? So that is the problem with horizontal scaling. And what is the other problem with horizontal scaling? The other problem is fault tolerance, also known as partition tolerance. Okay, partition tolerance. So now what is partition tolerance? Partition tolerance means that any one of these servers crashes. If any one of these servers crashes, then there is a problem. Again, the load starts increasing in the remaining servers, isn't it? The load starts increasing in the remaining servers. So this is a problem. So we have a solution for that as well, but that is something we will be discussing in the next class. Okay, in the next video. But till then, remember that fault or partition tolerance just simply means that there are multiple systems, devices in a distributed system in horizontal scaling. If any one of those fails, which is a possibility, isn't it? Which is a possibility, then that is called as fault or partition tolerance. Okay. So that's it for today's video, and I'll be seeing you all in the next video where we will be covering how to save ourselves from fault tolerance or partition tolerance. Okay. And if you want to learn these concepts in a much more in-depth manner, and you want to prepare for Mang-based companies or similar top-notch product-based companies, and you want to learn directly from developers who are working at Mang like me and other people, then do join Codekerdos. And I'll see you all in the next video.